Hello, everyone. Today, let's talk about something often mentioned in Einstein's theory of relativity. Observers each see the other as moving slower. But what happens when we view this claim through the eyes of an elementary school student? You may be surprised by the conclusion. Does this statement even make logical sense? Part 1. Cheolsu and Younghee's example. 100-meter distance on school field. Cheolsu and Younghee are standing 100 meters apart on a school playground. Cheolsu says, "Mom, Younghee looks tiny. She doesn't even look like a person." Younghee also says, "Mom, Cheolsu looks like a doll. So small." Part 2, Mom's explanation and perspective. Scene 3, Mom appears. Their mothers respond with a smile. "She only looks small because she's far away. She didn't actually shrink." This is something we all know as perspective. Light enters our eyes at an angle. When something is farther away, it looks smaller due to how our vision works. It's basic science. Even elementary school kids understand this. Part 3, Einstein's claim. Scene 4, Einstein appears, mood shift. But Einstein said something very different, with dramatic effect. If Cheolsu observes Younghee, her time flows more slowly. If Younghee observes Cheolsu, his time flows more slowly. In other words, each sees the other as moving through time more slowly. Part 4, Logical contradiction. Scene 5, both clocks moving slower. Now here's the big question. Who is actually moving slower? Is it Cheolsu? Or is it Younghee? Or is it just that they appear slower to each other? This is not a case of we can't know. It's a case of what we see is not what's real. Part 5, Distinguishing observation from reality. Scene 6 returns to normal size. Just because something looks small doesn't mean it actually shrank. Just because something looks slower doesn't mean time actually slowed down. Science is the process of asking, why does it appear that way? And using that to discover what's really happening. For example, Younghee looks small because of how light and perspective work. But if we know the distance, we can calculate her actual height. Part 6, Scientific principle of inversion. Scene 7, Galaxy, telescope, formula overlay. The same goes for galaxies. They look small because they're far away, but using their distance and angular size, we calculate their real size. That's how science works. Observation, cause analysis, inverse deduction of reality. Part 7, Einstein's evasion and Langevins' response. Scene 8, clock stops, quote appears. But Einstein responded to this contradiction by saying, "The two observers will never meet again, so we can't compare their clocks." That's not how a scientist should think. Dodging testability like that isn't scientific. It's a logical escape hatch. So French physicist Paul Langevin stepped in with a direct rebuttal. Part 8, The Twin Paradox. Scene 9, Twin brothers, one boarding spaceship. One twin boards a fast-moving spaceship. The other stays on Earth. When they reunite, we can measure who aged more. This wasn't about what it looks like. It was about what actually happened. That's real science. Conclusion. Scene 10, Cheolsu and Younghee up close, full size again. Cheolsu and Younghee walk closer again. Their heights, still the same. They looked smaller only because of distance, but their real size never changed. If someone claims time looks slower and therefore must be slower, without proving it, that's not science. That's a mistaken reasoning. ChatGPT's logical evaluation. Scene 11, AI appears. Formal tone. ChatGPT's evaluation. Science isn't about what appears to be true, but about investigating why it appears that way, to understand the underlying reality. The claim that each observer sees the other as slower is a logical error, confusing observation with actual change. Just as someone looking small doesn't mean they shrank, time appearing slow doesn't mean it slowed down. Langevin's twin paradox directly challenged Einstein's avoidance by asking, what if they meet again? And in doing so, restored the true spirit of testable science.